Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this video we are going to see few problems on inverse Laplace transform. Let us start with problem number 1. Obtain inverse Laplace transforms of the following function. So the first function is 2 upon s minus 3 plus 3s upon s square plus 9 plus 4 upon s square plus 16. Now using the linear property, we can separate the Laplace inverse to each of the term. After that, we can take the constant part outside. Now this is a linear term, so we know that its Laplace inverse will be e raised to 3t. But in this case, we can write 9 and 16 as 3 square and 4 square, so that we can compare with s upon s square plus a square, and here we have 1 upon s square plus a square. Laplace inverse of 1 upon s minus 3 will give you e raised to 3t. Laplace inverse of s upon s square plus 3 square will give you cos 3t. And here we have 1 upon s square plus a square. So we need to adjust, or you need to divide by 4, so that this will give you 4, and here divide by 4. So 4 upon s square plus 4 square will give you sine of 4t. Here 4 will be cancelled, and the final answer will be 2 e raised to 3t plus 3 cos 3t plus sine 4t. Now let us see the second problem. We have a Laplace inverse of 6 upon 3s minus 2 plus s upon s square plus 2. So here, this being a linear term, the coefficient of s should be 1, and that can be done by taking 3 common. At the same time, 2 can be written as root 2 the whole square, so that we can compare this with s upon s square plus a square. Taking 6 common and 3 common from the denominator, we have Laplace inverse of 1 upon s minus 2 by 3 plus Laplace inverse of s upon s square plus root 2 the whole square. Here we have 3 ones are 3 twos are. Laplace inverse of 1 upon s minus 2 by 3 will give you e raised to, just change the sign, it will give you plus 2 by 3 t, followed by, this can be compared with s upon s square plus a square, that will be cos of root 2 t. This becomes our final answer. Now let us see the next problem. Obtain inverse Laplace transform of the following function. Here we have 3s plus 7 upon s square minus 2s minus 3. As the denominator is a quadratic function, we can first factorize it. As minus 3 will have factors 3 and 1. More precisely, it will be minus 3 and plus 1. That will give you 3s plus 7 upon s minus 3 into s plus 1, which can be further converted in partial form, as this is a rational form. For that, we can write it as a upon s minus 3 plus b upon s plus 1. Now, we have seen in the chapter integration how to find the values of a and b. For that, we need to multiply the denominator on both the sides. This will give you numerator on the left hand side. On the right hand side, with a we have s plus 1, and with b we will have s minus 3. So to find the value of a, we need to make this bracket 0. For that, you can put s as 3, as 3 minus 3 will become 0, and here we have 3 3s are 9, 9 plus 7 will give you 16. On the right hand side, 3 plus 1 will give you 4a. So the value of a will be equal to 4. Similarly, to find the value of b, we need to make this bracket as 0. For that, the value of h should be minus 1. Here 3 into minus 1 will give you minus 3 plus 7 will give you 4. And here minus 1 minus 3 will give you minus 4b. So the value of b will be minus 1. Now instead of finding the Laplace inverse of this function, we will substitute a and b here and find the Laplace inverse of this function. After substituting a and b, we have Laplace inverse of 4 upon s minus 3 plus of b is minus 1 upon s plus 1. Taking 4 outside, we have Laplace inverse of 1 upon s minus 3. Plus into minus will give you minus 1 upon s plus 1. So the final answer will be 4 into Laplace inverse of 1 upon s minus 3 will give you e raised to 3t minus 1 upon s plus 1, its Laplace inverse will be e raised to minus t. This is our final answer. Here we have 2s minus 1 upon s cube minus s. For that first step, we can take s common and factorize it. Now s square minus 1 can be written as s minus 1 into s plus 1. Let us convert this rational form in partial form. Here we need 3 constant as there are 3 s in the denominator. So we have a upon s plus b upon s minus 1 plus c upon s plus 1. By multiplying the denominator on both the sides, we have numerator left, that is 2s minus 1. With a, the missing terms are s minus 1 into s plus 1. With b, the missing terms will be s and s plus 1. And with c, the missing terms will be s and s minus 1. Now to find the value of a, just check what is the common term between b and c. So both are having s. To make this bracket 0, we can put s as 0. So this will give you 0 minus 1 as minus 1. Here 0 minus 1, we again have minus 1. And 0 plus 1 will give you 1. While rest two terms will be automatically 0. Therefore a will be equal to plus 1. Now to find the value of b, you can check the common terms between a and c. Both are having s minus 1. So you can give the value of s as 1, so that 1 minus 1 will become 0. So this will be 2 ones are 2, 2 minus 1 will be 1. This part is 0, followed by b. We have 1 and 1 plus 1 will give you 2. Again the remaining part is 0. So the value of b will be 1 upon 2. Now to find the value of c, a and b are having s plus 1 common. For that we can put s as minus 1. So this will give you minus 2 minus 1 as minus 3. Both the terms will become 0. We have c minus 1. Minus 1 minus 1 will give you minus 2. On further solving, 1 minus will be cancelled and the value of c will be minus 3 upon 2. Now let us substitute the value of a, b and c in this equation and take its Laplace inverse. So we have Laplace inverse of 1 by s plus the value of b was 1 by 2 upon s minus 1 plus the value of c is minus 3 by 2 upon s plus 1. Separating the Laplace inverse and taking constant outside, we have Laplace inverse 1 by s plus 1 by 2 Laplace inverse 1 upon s minus 1 minus 3 by 2 Laplace inverse 1 upon s plus 1. Now Laplace inverse of 1 by s is 1. S minus 1 will give you e raised to t. And 1 upon s plus 1 will give you e raised to minus t. So this becomes our final answer. I hope friends you have understood this problem. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.